Hi everyone, welcome back to the next lesson in the permutation combination chapter. In the last lesson we have seen the NCR formula and its various ways of writing it, etc. One piece of advice about the NCR also is that when you start solving questions on permutation combinations, you'll start seeing a lot of questions or a lot of calculations which will keep happening all the time. So for example, you might, if you solve 100, 150 questions on PNC, permutation combination, you might see 5C2 at least 5, 7, 10 times. And once you start identifying that the value of 5C2 is always 10, you can maybe start memorizing those numbers. So 5C2 is 10, 7C2 is 21, just so that you don't have to derive it every time. So whatever standard numbers you might come with an 8C3 or 8C4 for that matter, or a 9C2 kind of numbers. So you can just start retaining those numbers rather than just putting it or solving it on your pen paper. Also take it into your mind so that those numbers start getting retained. Don't try to memorize them, but what will happen is that the more important NCR values will automatically keep coming to you in front of you all the time. So whenever it comes to in front of you, whenever NCR comes in front of you or 7C3 comes in front of you, if you have by default known what 7C3 means, so you can automatically write the answer without actually having to to calculate. And that might be an important aspect of how you raise speed in permutation combination. But before I have to go into questions with you on the use of NCR. But before I go to NCR, uses of NCR and questions for NCR, before I go to that, if you remember, we started the last class by talking about 4 distinct objects or 4 distinct people, and you had to select 2. In a parallel scenario, if I talk about 4 identical objects or 4 identical people, and I want you to select 2, and in both cases we are talking about number of selections. In both cases, if you are talking about number of selections, you will realize that in both cases my selections will have a slightly different hue, because here my selections were differing from point to point. But in this scenario, if I am talking about number of selections, I want to select 2 from 4, there is only one selection. In this case, I have 4C2 selections. In that case, I have only one selection. So this is the parallel formula for selecting. It's not actually a formula, it's just a realization that if you are selecting from or selecting R objects from N identical objects, that's the key word here. And this is where you realize why I was underlining that word of N distinct objects in the NCR formula. So you're selecting R objects from N identical objects. In such a case, the number of selections is always 1. There is no formula in this. The number of selections is always 1. There's no formula, there's no count. It's simply 1, because whatever you do, you'll be selecting only 2 ways, right? So to give you an analogy of this situation, suppose you go to somebody's house and they keep 4 kinds of sweets in front of you, and you eat 2 of them, and then somebody asks you, what did you eat? In this scenario, you have 6 different answers to give depending on what you ate. But you go to somebody's house and they put 4 laddus in front of you and you ate 2 of them. The situation is over. There's no variant to which laddus you ate. You ate 2 laddus, 4 identical laddus were given to you. As far as they were identical, you had, when you said that you have eaten 2 of them, there's no further count required, because that's the only count available for that, right? Whereas in this case, I can further ask you this question, which 2 did you eat? And you have 6 different variants to the answer you can give me, A, B, A, C, A, D, and so on. And that's how this is different from that. And in my counting of formulas, for the PNC chapter, I call this the second one and that the first one. Understand the situations. every question in PNC will, in selection question, will be using either one or two, or there might be some questions which will be a mix of the two. And which one to use is very simple, simply identified in a question by understanding whether the objects from which you are selecting are distinct or identical. So with this brief intro to the first two formulas, let me go ahead with showing you a few questions on some direct questions on NCR, on the use of NCR specifically. And of course, when I tell you that there are 14 formulas, let me also tell you one more thing. I'm writing it in a particular way because that's how I'm going to teach you these. If you remember, we had talked about selections having the first 6 formulas, distribution having 2 formulas, and the 9th formula is shared between distributions and arrangements. And why I've written it in 2 columns, at least the first 2 parts, is because this is selection from distinct objects, this is distribution of distinct objects, this is selection from identical objects, and this is distribution of identical objects. So that's why I'm putting them this way. So we have seen formulas 1 and 2, and before we move to the other formulas, one more thing I want to tell you why I listed this down is that although there are 14 formulas in this chapter, the critical ones on which 90% of the chapter hinges are 1, 9 and 7. So 95% of the questions you will see in this chapter will get solved using 1, 9 and 7. So if you understand 1, 9, 7 well, you're more or less done on this chapter. So my focus will now shift onto formula 1 and questions based on this. And as I said, formula 2 is pretty much not usable or not used much except in scenarios where you have a mixture of selecting from a mixture of identical and distinct objects. So anyway, let's come back to the first question that I want to show you today. And this question is that suppose there's a room with 12 people and everyone shakes hands with each other. Everyone shakes hands with each other. Then what is the number of handshakes? What is the number of handshakes that will happen in the room? This is the first application of the NCR in an actual situation or an actual problem. And to understand why NCR applies here, let's take a scenario where there are 3 people, A, B, C, and you want to count the number of handshakes if everybody shakes hands with each other. So if you're trying to count the number of handshakes, you will be saying that the first handshake is the handshake between AB, the second handshake is the handshake between AC, and the third handshake is the handshake between BC. And when you're doing this, effectively this list is the same list that will get created if you select 2 people from 3. If you select 2 people from 3, this is going to be the exactly same list, right? And hence, in this case, if I want to find the number of handshakes, I can do it using 3C2. In this case, if I want to find the number of handshakes, I can do it using 12C2. So that's a simple question, straight question. NC2, when you're talking about 2 people shaking hands from n people, the generic solution always is going to be number of handshakes is NC2. Right? Now, this question can also be asked in a different scenario, the handshake question. Let's say in a room there are 8 men and 6 women, and handshakes are held between 1 man and 1 woman. Every man shakes hands with every woman once. So in this scenario, how many handshakes will happen? So if you want to take a smaller case to visualize, let's say there are 3 men in the room A, B, C and 2 women in the room D, E, and they start shaking hands with each other. Then what will happen is, if you want to see the handshakes, one handshake will be A's handshake with D, the second handshake will be A's handshake with E, the third handshake will be BD, the fourth handshake would be BE, the fifth handshake would be CD, and the sixth handshake would be CE. So you can see very clearly in this scenario there are going to be 6 handshakes that are going to happen, and this 6 on the NCR logic will get done using 3C1, because what you are doing is you're selecting a man and selecting a woman. So select a man and select a woman. So 3C1 is the number of ways in which you can select the men, and in PNC and probability, the AND conjunction is always replaced by into, and the OR conjunction is always replaced with OR, with plus. So in this case, 3C1 into 2C1 will become the number of handshakes, and you can confirm this, that there are actually 6 handshakes happening here, because we have pretty much made the comprehensive list in this case. So if you are trying to solve the same thing for this situation, the number of handshakes would be 8C1 into 6C1, which would be 48. Alright, and this question can be asked in an opposite way also, and that opposite way is that in a room there were a certain number of people and everybody shook hands with each other, and it was found that the number of handshakes was 153, and I ask you to find the number of people in the room. How many people were there in the room? Find the number of people in the room. So in this scenario, what happens is that because the room has, let's say, n people and everybody shakes hands with each other, the number of handshakes is NC2, and this value is given as 153. And when you expand the value of NC2, you know the value of NC2 is n into n minus 1 by 2, which is 153. And if you take the 2 to this side, you'll get n into n minus 1 equals 306. And because n into n minus 1 is 306, to solve this, there's no need to go to the quadratic equation. You can do a trial and error and look at the unit digit of the answer. So for example, 20 into 19, if I take n as 20, n minus 1 is 19, this value does not match the unit digit of 6, because 0 into 9 will give me a unit digit of 0. So this can't be the value. 19 into 18 will give me a unit digit of 2, so this can't be the answer. If I use 18 into 17, I get a unit digit of 6. And in the relevant range of values, this is the only value that gives me a unit digit of 6. And if I check, I can see that 18 into 17 is indeed 306. So that means the value of n is 18, and that's the correct answer to this question. So that's how you do this question when you are given the number of handshakes and not given the number of people. So one last modified question on the number of handshakes is that in a room with men and women, everybody shook hands with each other. Everyone shook hands with each other. And then the piece of information given to you is number of handshakes between a man and a woman. Sorry, number of handshakes between 2 men is 153, and number of handshakes between 1 man and 1 woman is 180. So what is the total number of handshakes in this room? What is the total number of handshakes in the room? So in this question, you have to solve this in three parts. The first part is to understand how many men there are. Now if there are 153 handshakes between two men, we just solved this question through that process, that n into n minus 1 should be 306. We can come to the conclusion that n should be 18. That is the number of men. Or let's call it m. Or let's keep it as n. So number of men, n is 18. Now let's think about the number of women. Let's say the number of women be w. So according to this, NC1 into WC1 should be 180. And NC1 is n and WC1 is w. So n into w should be 180. And we have found out n from the first interpretation in this problem, that n is 18. So 18 into w should be 180. So the value of w will be 10. And that's the number of women. So from this point you can solve the question in two ways. You can either realize that now there are 18 men and 10 women in the room, and if everybody shakes hands with each other, the number of handshakes overall will be 28C2, which would be 28 into 27 upon 2, which is 14 into 27. And 27 tens are 270 and 27 fours are 108. So this value will be 378. This is one way you could do this. Another way you could do this is that if you now calculate, now that you know the number of women is 10, if you calculate the number of handshakes between two women, that would be given by 10C2, which is 45. And since there are only three kinds of handshakes in a room with men and women, there are three kinds of handshakes: man-man, man-woman, and woman-woman. So if you add all of them, you'll get the same answer of 378 handshakes. So this is the handshakes question. It's a straight application of the NCR formula. And in the next lesson coming up, we'll be looking at other applications of the NCR formula. I hope you enjoyed this. PNC, as I told you, is one of the easiest chapters to understand, provided you pick it up correctly. So make sure that you're doing the parallel questions along with this, and also understanding each of the concepts that I'm talking about here. Thanks a lot. Bye for now.